equals 9 people because the first sandwich, they ate 10 of the pieces, right? So Jackson, you have a question?
I was just going to say
The answer? Okay. So you see how 19 minus 10, we have 9 people left that still needs to eat. So 1, 2, 3, 4, 5, 6, 7, 8, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So how much of this sandwich did they eat? What fraction? Gauge. 9/10 exactly. So they ate 9/10. Does that make sense? So this is what you could write on that line, or you could just write 9/10. Alrighty? Does that make sense?
Yeah.
So all you need to write is 9/10. All you need to write is 9/10 because 9 pieces they ate on sandwich 9. Okay, and then it says, what fraction of the second sandwich is left over? Well, if they ate 9/10 of the sandwich, Michael, how much is left over?
1.
1 what? 1 over what? There's how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're saying there's 1 left over, that would be 1/10. There's 10 pieces. Does that make sense? So 1/10. Yep. So all you would write is 1/10. Good job, bud. Then it says, what number tells how many super sandwiches the campers ate in all? So, how much did they eat total? So, they ate 1 full sandwich, and they ate all but 1 piece of the next sandwich. Yes, Zach?
1 and 9/10.
Yes, do you see that? Because look, if you did not put that into an improper fraction, you would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And it would be 19 over 10. Okay? 19 over 10 equals 1 and 9/10. Because 10 can go into 19 times how many? How many can 10 go into 19? How many times? Yes, Eliza? What? Be confident, yes. And then how many is left over? Eliza, continue, you're fine. How many is left over? If 10 can go to 19 times, that's 10, right? And then if 10 can go to 19 times, you divide it. There we go. Does that make sense? Because you have 9 left over. 10 can go to 19 times, which is 10, and then you have 9 left over. Okay? Yeah. Good job. Good job. Flip the page to 208. I want to show you guys something. If our fraction, eyes on me, if our fraction is 15 over 5, it's pretty much saying 15 divided by 5. You're just trying to see how many times 5 can go into 15. So if we change this to a mixed number, what would it be? Or it actually would be a whole number, but what would it be? 3. Just 3, right? Because 15 going, or 5 going to 15 3 times. Does that make sense?
Mm-hmm.
So if it was 17 over 5, what would that mixed number be? Michael? So 15 can go to 17 3 times, just 15, right? And then how many do we have left over to get to 17? 15, 2. So then it'd be 2/5. Does that make sense, Michael? It's 15. Keep going. 17. 3 times is 15. But our number 17. So we have to see how much is remaining. Okay? So then, if we look on this page right here, it says change each mixed number to a fraction and each fraction to a mixed number. So this one gives us a mixed number now. It says 5 and 2/3. Okay, so we're looking at this, right? And we're thinking, how do we change this to a fraction? Well, it's pretty much just saying you're taking 3 5 times, right? So 1, 2, 3, 4, 5. And then it's saying, oh, but you have 2 left over. So you're taking 3 5 times to get your 5. So 1, 2, 3, 4, 5. Oh, we got our whole, right? But oh, we still have 2/3 left. So that's why it's 2/3. So then, how many do we have total here? How many shaded? How many do we have shaded? Olivia? Total. How many total spots do we have shaded? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So when you're changing this to a fraction, it would be 17/3. Because you're trying to change this to a fraction of thirds, right? You're not wanting it a mixed number. Okay. So if we look at another one on that line, you would write 17/3. Yeah, this starts with number 5. Yeah, I don't really know why it doesn't start with number 1, but yeah, number 5. Okay, so let me show you another one. Oh, you have a question for me?
I'm kind of confused. I don't. Like, isn't 17 more than 3? So wouldn't there have to be a whole number in front of it?
Yeah, okay, watch this. Yeah, so let's go back. But what it's asking us to change this number to a fraction. Okay? This is a mixed number. This is not a fraction, okay? So it's saying change this mixed number into a fraction, also called improper fractions. Okay?
It's actually called a fraction greater than 1.
Fraction greater than 1.
Which is the new terminology as opposed to an improper
Proper
fraction. So it should be called, and that's how we were taught, but I went to a special training and they told us that we need to look at calling it a fraction greater than 1. And what you're doing, Caroline, is making an equivalent. So you're making an equivalent fraction that's greater than 1 to that mixed number. So they would actually equal the same thing.
Okay. So you're so you're making an equivalent fraction. This is a mixed number, now you're putting it into an equivalent fraction. It's saying we have 5 wholes of 3, right? So we're looking at our thirds. 1, 2, 3. You're taking this 5 times. So look, taking this 5 times. If you look at this, what's 5 times 3? Okay, and then we have 2 remainders, so 15, 16, 17. It's kind of an easier way to do it. Is that an easier way to do it? Does that make sense? But it's like that because you have a 5 in the front, so you have 5 wholes, and then you have 2 remainders, 2/3 remaining. Okay, so now if we're looking at 3 over 3/7, how many wholes is it saying that we have? 1/7. How many holes do we have? Sammy? How many holes? 3. So it's saying we have 3 holes. And then how many, guys, this number right here in your mixed fraction, that's your remainder, okay? So then how many do we have remaining? 3. So then it's saying, oh, we also have 3/7 remaining. 1, 2, 3. 1, 2, 3, 6, 7, 7. Okay, and then it's saying, oh, 3 remaining. 1, 2, 3. If each one of these has 7 pieces, 7 times 3 is what? 21. Add our remainder. So then we'd have 24 over 7. Does that make more sense?
Yeah.
Okay. Honestly, that's the way I like read it. If I look at a fraction, I'm like, oh, I have 3 of these 7s. I times 7 times 3. Add my top number. It's just a lot easier. To me, like, I understand them showing us this, but it also can confuse you at the same time because it's a longer step and it's dragged out. Does that make sense?
They just want you to understand what the reason is behind multiplying and adding. So it's like you visually have 3 whole candy bars that are broken up into 7 pieces, and then you have another candy bar that was broken up into 7 pieces, but maybe Harry ate 4 of those 7, so now there's only 3 left. So how many do you have? You have
20
pieces. Do you have? You have 21 plus 3 pieces over your 7. Does that make sense?
Yeah.
Yeah, you're doing a good job.
So let's do another one. 6 and 6 tenths. Okay, I'm not going to draw it out this time. So if we're looking at this, what do I do? What do I do first? Who wants to walk me through this? Olivia. Is what? Okay, and then how many do we have remaining? How many pieces do we have remaining? 6 pieces, which is what? 66 over what? Does that make a lot more sense?
Yeah.
Okay. Okay. So now what I want you to do is I want you to work on 9 and 11 with your partner. 9 and 11 with your shoulder partner. Okay, you can work either Olivia or the big number comes in If you guys are waiting, you can go ahead and do 8 and 10. If you're waiting. All right, class.
Yes.
Class.
Yes.
Eyes on me. Who wants to walk me through number 9 that you guys did together? Katie and Zach.
Okay, first do 2 times 8.
Which was what?
16.
16.
Then you add 7 more,
Which is what?
23.
So then our fraction that is equivalent is what?
23.
Perfect. Does that make sense?
Yep.
All right. What about Sammy and Caroline?